All right, here we go. Number one, use the graph of the function to find the domain and range of f. All right. See, can I blow this up a little bit?
Can you
Hmm.
show the instructions one more time?
Okay. Use the graph of the function to find the domain and range of f. Enter your answers using interval notation. So, can someone tell me how do you find the domain, or what does the domain involve?
The
What
X
does the
value.
domain?
X value.
The point.
X.
Oh, I'm sorry.
All right, very good. But we have to
X.
put yes in interval notation. So what we're looking for is first the leftmost x value. So tell me, someone, what is the leftmost point? I know it's not included because it's an open circle, but what is the leftmost point if you had to figure that out?
Negative 2.
2 and 7.
-2, 7, right? So which number is the x? The -2 or the 7?
-2.
Negative 2.
-2. So we started from -2. I don't know if y'all can see my little. Can y'all see an arrow?
Yeah.
You can? Okay. This is -2, 7, right? Because this was -2 here. So that's why, and you all see the answer because this is my side. That's why it's -2 first. And why is it a parenthesis?
Because it's an open
Not
circle.
included.
It's an
This
open
is a,
circle.
yep, it's open circle. So that's why it's a parenthesis at -2. And then it goes all the way to the right, all the way over here. This is the rightmost point. It's the point that's the farthest to the right. And that point, tell me what the point is.
2, 7.
2,
2.
7. 2, 7. But since we're talking about domain, we're just going to put 2 because domain involves the x values that this graph covers. So from -2, from -2 to +2, why in this case it should be a bracket? Why should it be a bracket?
Full circle.
Because it's close.
Close circle.
It's
A close
closed.
circle.
So this is the answer from -2 to 2, but -2 is not included. That's why we have a parenthesis because it's an open circle. 2 is included because it is a closed circle. So the graph is touching it. On time when you know the graph is not touching it when you see an open circle. Everything else is closed. All right, range involves the y values. Again, we write interval notation from least to greatest. So we always start with the bottommost y. The bottom of this graph is right here, these 2 points right here. What y corresponds to the bottom of this graph?
Negative 2.
-2. And the topmost point, this one, because this one's not included. So I'm going to go to this one. What is this y value that corresponds to this?
2.
7.
Y value? 7, right here. So range is 7. So that's why we're looking at the y-axis for the range, and we look at the x-axis for the domain. So this is 7, corresponding to this point. Y equals 7, corresponding to this point, 2, 7. All right. And there should be brackets on both because they are included. It does cross, it does touch the -2 on the y, and it does touch because it's closed, it's not open. So it should be a bracket for both ends of that. Okay. Any questions about that piece, domain and range? And you look like you got everything else right, Monish. All right. How are you feeling, Monisha, about that?
I feel better, thank you.
All right. Anybody else? You have a challenging question. All right. We're not done, so maybe I will address it today. So we shall see. All right, Zoe.
I can wait if you want to, but I had my problem right here.
Have we covered it already?
It's I don't know, ma'am. You talking about today's class?
Tuesday. Did we cover it Tuesday?
We didn't do any problems. So we did strictly notes Tuesday. So no, ma'am.
All right. I'm just saying, did we cover the concept?
Oh yes,
If
we
we
did. Yes, we did. I'm sorry. Yes, we did.
Okay. All right. Do I need to pull up your homework or can I just
I can give you the problem. I can just give you the problem.
can I write it on the whiteboard? Does it involve a graph that I need to pull up?
No, ma'am. It doesn't involve a graph.
Okay, good.
Well, the part that I needed help with doesn't involve a graph. I don't say
Okay.
it was problem 8 though on the homework.
Problem 8. Hold on. Me pull up my whiteboard. Mm-hmm. All right, what is it, Zoe?
Okay, so it was 2x. Okay, this is the equation. I guess it'll be f of x equals 2x squared.
Mm-hmm.
F equals 2x squared minus 7x minus 15 equals 0. Well, no,
So
f of x equals 0. I'm sorry.
all right, so we're supposed to be set f of x to equal 0.
Yes, ma'am.
All right. So we're just setting 2x squared minus 7x minus 15 to equal 0. All right. All right. So there are steps to whenever you are solving an equation that has the degree is higher than 1. What's the degree for this equation? What's the degree of this polynomial on the left? It's 2. So anytime you have something that's 2 or higher from your degree, it usually involves factoring if you can factor. So our first step would be to factor. What type of polynomial do we have here? If you had
A trinomial.
It is a trinomial. It's a trinomial. So you could use the AC method. Have y'all ever heard of the AC method?
Yes, ma'am.
All right. Where you multiply your A. This is your A because AC method is basically we're in this form right here. We're multiplying the A times the C, which stands for the constant, which is negative 30 in this case. So we want to find factors of negative 30 that add to what number?
Negative 15.
Negative 7, the number in the middle. All right. I'm not sure if y'all familiar with AC method, but you can always use trial and error. That works fine too. Sometimes it just takes longer to figure out the factors when you're just doing it by trial and error. AC method will get it to you a little faster most of the time. All right, so you have, let's write out the factors of 1 and 30 in order. So 1 and 30. Put in the chat what are some other factors. Let's try to do it in order though.
2.
Put in 2 and
2 and 15.
all right. Give me something else. Let's see what y'all say in the
3
chat.
and 10.
3 and 10. Somebody else.
6 and 5.
6 and 5. All right. Are we done? Is that good?
I think
For
so.
the factors of 30. Now, since it was a negative 30, we got to manipulate signs. We want factors that will multiply to give us negative 30, but add to give us negative 7. Negative
Is it
7.
going to be negative 10 plus 3?
Negative 10. Okay, yeah, that sounds good. Negative 10 times 3 is negative 30, but also negative 10 plus 3 is negative 7. All right, therefore it works. All right, so I'm going to rewrite the polynomial as 2x squared, and you could put minus 10x, for example, plus 3x, because the middle has to equal negative 7x, not just negative 7, or else you will change the whole problem. It has to equal negative 7x. All right, we factor by grouping when you have 4 terms. That's 2x times x minus 5 plus 3 times x minus 5, which is x minus 5 times 2x plus 3. So those are the factors, or 2x plus 3, same thing, times x minus 5. And you can always check by doing what?
4.
4. Yep, multiplying that out just to make sure before you move on. So 2x squared minus 10x plus 3x, it works out. What's the next step?
You set all of it to 0.
Set each factor to 0. So 2x plus 3 equals 0. And what word we normally put next in math?
Or.
Or. Thank you. X minus 5 equals 0. Over here, we're going to subtract 3. 2x equals negative 3 divided by 2. X equals negative 3 halves is one of the solutions, or one of the zeros. All right, and then add 5. X equals 5. All right. What was the degree of this polynomial again? What was the degree?
2.
So 95% of the time, you're going to have 2 solutions if your degree was 2. If you had your degree was 3, you'll have 3 solutions 95% of the time. All right, Zoe?
You answered my question. I was just about to ask, so I'm only going to have 2 answers. So, but you answered my question.
Right, that's all we got. See, that's all that popped out. See that? X equals negative 3 halves and x equals 5. Don't make up one now. That's only 2 things. We only had 2 factors, right? Yeah. All right. Maurice, what's your question?
So this is in a situation where we were just asked to factor. Like I understand what's going on, but I'm not understanding why we did the process of that.
Okay. Zoe, would you read the instructions to your problem from number 8? And all y'all number 8 is going to be the same. So you could print out your WeatherSign homework. What does it say?
What if I wrote it down? I was supposed to put all of my solutions in a comma separated list. I can't necessarily remember. I just wrote like the problem down.
Does it say find the zeros, or does it say?
Yeah, that's what it was. It was like find the
zeros.
Yes, ma'am.
Okay, so if it said find the zeros, that's how you do it. If it says set f of x to equal 0, same thing. That's the same question, really. If it says set f of x equals 0, or if it said find the zeros, this is what you do, Maurice.
Got you.
All right. Now, finding the zeros is the same thing as what, you guys? Finding the what?
Function?
No.
Was it the y-intercept?
Not the y-intercept, but the
The x-intercept.
X-intercept. So in algebra class, before this class, you all had to find the x-intercepts. Guess what? You're doing the same thing right now, but in pre-cal, we call it finding the zeros of a function. All right. So where did we end last time? Did we do A?
We did A and B. We stopped at C.
Okay. Okay, good. So as a reminder, what we are doing, we are finding the zeros of a function. So tell me what to write for C.
Set your problem equals 0 first.
Yes, so tell me exactly what I need to write, Zoe.
You need to write 2t minus 3 over t plus 5
Yep.
equals 0. And
Yes.
then
Try to figure out how to solve for T.
yes, ma'am.
All right. Because does anyone know? We got a rational function right here. It's a fraction, a whole fraction. What would y'all do?
You gotta get rid of the you gotta get rid of the t plus 5 in the denominator, so you gotta multiply it.
Yes. By what?
T plus 5 on both sides.
Very good. Very good. I know it seems blasphemous, but we're going to multiply both sides by t plus 5. It's a little weird, but that cancels that out. T plus 5 is over 1, so the t plus 5 in orange in the numerator cancels out with that t plus 5 in the denominator. All right, so we have 2t minus 3 equals what's on the right side?
T plus 5. No.
It's 0.
0, right? Because anything times 0 is 0, right? Anything times 0 is 0. Then we're going to add 3 to both sides. We get 2t equals 3. Then we do what?
Divide.
Divide
or 2.
by 2. Yep. 2 divided by 2 is really 1. We somehow say it cancels out. So t equals 3/2. All right. What I want you to do is use something called Desmos to graph this. Did everyone download Desmos? That's an app on your phone. All right. So if you have not, go ahead and download Desmos, the Desmos app, to your phone. So whenever it says something about on your homework, use a graphing utility. What could you use? If it says on your homework, use a graphing utility. What could you use? Desmos. All right. Unless you have a graphing calculator. You may have a graphing calculator. So that works too.
Dr. Thomas,
Yes.
is it just going to say Desmo graphing calculator?
Is it green with like a parabola on it or something?
The one with the parabola, it said Desmo scientific calculator.
I want to graph. Yeah, we want to graph.
Okay.
You all will have moved up to graphing now. All right. Any other questions? I'm going to use X instead of T, and I want you to use X too. It doesn't change anything. All right, so f of x equals, what I'm going to do right now, what should I do right now so that my numerator stays in the numerator? How would y'all enter this problem? We got 2t minus 3. Would you just type 2t minus 3?
Yeah, and you probably will put the other one on too.
But what would I do now? To put, what's the bottom? What's the denominator?
Won't you have to
T
put
plus
it on the next line
what next line?
where it says 2? Or would you have
No,
to
it's
use
the same
parentheses or
function.
something?
This is the same function. So what do I need to do to make this into a fraction?
Put it over 1.
Put it how?
Forward slash.
Forward slash. But if I do this, see that? See what happened?
So would you have to go to your function keys and see what you have? Or
That's what I did. I went to functions
You
and
went to function?
functions and
it
miscellaneous.
should come up.
Okay. Okay, let's see. You went to function. You said miscellaneous. Okay.
And then yeah, that
What
d over dx.
No, that's derivative. Oh, hold on. Okay, hold on.
Then you can type it.
All right, 2x minus 3.
Mm-hmm.
Who taught me that? Kenna.
Yes, ma'am.
Kenna. Okay, thank you, Kenna. All right, 2x minus 3 over, what else?
X plus 5.
All right, x plus 5. Awesome. That's one way of doing it. Now, just in case you didn't realize, you could have just put that 2x minus 3 in parentheses / I think Merritt said that, and it'll do it for you. You see that? But I like that function one. Okay. So all the way into functions, miscellaneous, and then the d over dx actually work. That actually stands for the derivative, so I probably would have thought it didn't work. All right. All right, what did I say? The zeros, finding the zeros is the same thing as what again?
Finding the x-intercept.
So the x-intercept is the point that crosses what on a graph?
The x-axis.
The x-axis. So on your screen, you see my screen. You see where it's crossing?
Yeah.
All right. What does that have to do with our answer? We got an answer. Our answer was.
I'm guessing if we plug that in, we'll find the y.
What was the solution to C?
It's 3 halves.
3 halves.
1.5.
Oh yeah.
Thank you.
0.5. Yeah.
3 halves is the same thing as 1.5. We found a zero. We call it 3 halves. But guess what? The x-intercept. If I ask you to write the x-intercept out, I want you to write it as a point. How would you have written it as a point? The x-intercept. If I want you to, I said write it as a point for x. If I ask you for the x-intercept, how would you have written it? Or the
It'd be
t-intercept. Okay.
1.5 and then the comma, then 0.
Okay. So 3 halves 0 or 1.5 comma 0 or 1.5 comma 0. That's how you would write it if I ask you for the x-intercept. If I ask you for the 0, all you have to do is write t equals 3 halves. Oh, I'm supposed to say t-intercept. It's not x-intercept for this one. It's t-intercept. Why? I just want to make sure you understand it. Why I'm calling it t-intercept and not x-intercept.
Because they got h over t.
Our variable is t in this instance for C. It's not x. Okay. But I kind of switched it. I didn't want to cause any issues in decimal. It may not have even been an issue if I put t in there, but sometimes there's something else in math that involves a t, so I didn't want to confuse it. Maurice, did you have a question? I see your hand.
I probably should have raised it. I do have a question though. So the instructions for this particular problem was to find the 0 or the x-intercept. So this is a rational function. We set it equal to 0, and we multiply t plus 5 to both sides. I'm just walking through it to make sure I'm understanding this correct.
So when
And
you
that's
find the zeros, you set it doesn't even have to be a fraction or a rational function. You set them all equal to 0. That's the same step. But yes, because it's a fraction, you multiply both sides by its common denominator. Yep. Whenever you have fractions, you multiply. To get rid of the fractions, you multiply what they call the LCD. You probably heard of that, least common denominator, before. So, yep, it wiped it out, which is what we want.
okay.
All right. Let's move to the next concept, which is increasing, decreasing, and constant functions. Here's a look at an example of a graph, and I'm showing you what section is decreasing, what section is constant, and what section of this graph is increasing. Now, if you were tracing from left to right, starting with this point right here, and if you were tracing it with a pencil, are you going up or down?
Going down.
Going down. That's how you know it's decreasing on that interval. All right, it's decreasing on that interval. In the middle here, you tracing it from left to right, it's neither going up or down, so that's how you know it's constant. All right, and then this little piece here, you tracing it from left to right, is going up, so that's how you know that interval is increasing. All right, so increasing, decreasing, and constant functions look from left to right. Only use the x-axis to determine your intervals. Okay. This textbook exclusively uses parentheses for writing out the answers to intervals that are increasing, decreasing, or constant. So this section right here is unlike range, the domain of range, finding the domain of range, because you don't have to worry about is it a bracket or is it a parenthesis. For this concept, increasing, decreasing, and constant, you're going to use a parenthesis no matter what. All right. So let's start with the decreasing. So I know it's going to be parentheses no matter what for this concept. What x value corresponds to this point?
-2.
-2. And we got to figure out, where does it stop decreasing? It stops decreasing right here. What is that x value?
1.
X value.
0.
0. All right. It's not decreasing anywhere else. Now, on your homework, if it was decreasing on another interval, they want you to separate your intervals by a comma. Okay, so you'll put comma and put another interval, but that's for this particular image right here. There's only one piece that's decreasing, one interval. All right, now let's go to constant. I already know, again, it's automatically parentheses no matter what. Don't think about when it's brackets and when it's parentheses for increasing, decreasing, and constant. The only time you're going to consider when it's a parenthesis or a bracket is when you're dealing with domain and range for now. All right. Constant. It's constant. It picks up right here and ends right here. So what's the interval?
0 and 2.
Very nice. 0 to 2. All right. And then it's increasing from where to where?
2 to 4.
Yep. 2 to 4. So again, if you had to trace it from left to right, there you would be going up. So it's increasing from 2 to 4. So you're just looking again at the x-axis. All right. All right, let's move on to the next thing. even and odd functions. Even and odd functions. So I wanted you to take a first a look at even functions and how they look. Some examples of even functions are these functions. Notice what's different about these. They are symmetric in that if you fold it in half across the y-axis, wouldn't it be mirror images of each other? Y'all see, couldn't you just fold it right across the y-axis and it's symmetric about the y-axis? All right, so write this symmetric. And what's the root word of symmetric? So we can break that down.
Symmetry.
Symmetry. All right, symmetry means what?
You can draw a line through something,
Even.
or you cut it in half. It's even.
It's kind of even. They claim that well, I'm not gonna say that. All right. Yeah, symmetry basically means is one side is basically the mirror image of the other side. All right. Just like this V. If you folded it across the y-axis, it matches up, doesn't it? Cosine of x. Y'all hadn't gotten there yet. Some of you may go on to trig, so you'll deal more with those functions. This is a parabola. Again, if you folded it across this y-axis, it's the same. So that's an even function. Those are example even functions. Odd functions. Can you fold it across the y-axis and it does the same thing for these?
No.
Nope. All right. I'm gonna go ahead and tell you, odd functions are symmetric, and this is how they say it sometimes or write it out. Symmetric about the origin. I know that sounds weird, but sometimes you hear it like that. Or symmetric to the origin. All right. So really, you need to flip this part over here, and then also flip it again down here. So over the y and the x. All right. So you can take half of it like this, flip it over here, and then flip it across the x-axis. So that's a little bit more involved. But I wanted to show you how it will look on a graph if they were even or odd. But I'm about to show you now how could you tell if you actually have the function and you could do it algebraically. All right. Here are the tests for even and odd functions. The first thing we're going to do, we're going to substitute all of our x's with a negative x. The function is even if you get the same as the original function. That is, f of negative x equals f of x. Don't worry, I'm going to explain to you what that means. The function is odd if all signs switch to the opposite sign of the original function. That is, if f of negative x equals negative f of x. All right, here we go. Let's try out A. All right, determine whether the function is even, odd, or neither. Then describe the symmetry. I'm going to show you how to do it algebraically rather than looking at the graph. All right. First thing you do, substitute negative x for x. So f of, instead of x, we're going to put what in x's place right now?
Negative x.
Negative x.
Yes. All right. And then what we're going to do is clean up the right side. So we have 5. What else we have?
Plus 3x.
Plus 3x. Yeah.
Plus 3x. Very good. That's all we can do. Now, we're going to compare. This original function to this. Are they exactly the same?
No.
No.
No. So this is not 5 plus 3x. 5 minus 3x is not the same as 5 plus 3x. Therefore, we can conclude that it's not even, because it says the function is even if you get the same thing back as the original. So we know it's not even. Let's see if it's odd, because it could be neither even or odd. The function is odd if all signs switch to the opposite sign of the original function. Did all the signs switch?
No.
Trick question. You're right. Not all of them changed. Which one did not change?
5.
The 5. The 5 stayed positive. It was positive in the original function, and it's still positive in the new one, the f of negative x. So it's not odd either. Therefore, we say it's neither even or odd. It's neither even or odd. Therefore, it has no symmetry. Neither even or odd, no symmetry. All right. Let's look at the next one. F of negative x equals negative x to the 4 minus negative x squared minus 1. What is negative x in parentheses to the 4? We need to clean that up. Negative x in parentheses to the 4th power. Can we simplify that? Someone other than Kenneth.
Is it gonna be x positive x to the 4th power?
Positive x to the 4th power. Yes, because if it's to an even power, the negatives are going to cancel out. All right, because negative times negative times negative times negative all going to cancel out. So that is x to the 4th power minus, what about someone other than Merrick and Kenneth, negative x squared?
X squared.
Same thing.
It'll be x squared. But I brought down that minus sign. Okay. But inside the parentheses, negative x squared means negative x times negative x, which is positive x squared. But don't get that confused with the minus on the outside. Please excuse my dear Aunt Sally says I have to do that parenthesis first and those exponents first. All right, minus 1. All right, let's compare our original x to the 4th minus x squared to our new. Is it the same?
Yep.
Yeah.
Yes. So we can conclude. What can we conclude for this one?
An even function.
Even function. And what about the symmetry for even functions?
It's symmetrical.
Symmetric about what exactly?
The
y-axis.
Yes, yes. So if you graph this right now, and I'm not, y'all now have that resource, Desmos. You now know what that means. But if you graphed it, it would be, if you fold it across the y, it would be mirror images. Like it will actually match up on both sides. So symmetric about the y-axis. So all even functions are symmetric about the y-axis. All odd functions are symmetric about what?
The origin.
The origin. Just making sure you're still up. All right. All right, let's go to C. F of x equals x cubed minus 1. You try that one. I'll give you about 60 seconds to work on it and determine whether it's even, odd, or neither, and then describe the symmetry. All right, so f of something equals something cubed minus 1. So we have negative x, negative x. Okay. F of negative x equals negative x cubed. What is that? Negative x cubed. Negative x in parentheses cubed equals.
Negative x cubed.
So notice here we had an odd exponent. So it's going to be negative. All right, I'm going to write down my minus 1. Nothing else we can do here. We're going to compare our original with the new. Is it the same?
No,
No,
So what can you conclude from that that is not the same?
the
it's not
negative.
even.
It's not even.
Not even. All right. Did all signs switch?
No.
No,
No. So what can we conclude about this problem?
that it's not odd either.
Neither. All right. Neither. Therefore, what about the symmetry?
No
Not
symmetry.
No symmetry. All right. I'm going to make one up for you all. We got one more thing to cover that you're going to have to probably take notes if you printed these notes out early, because I kind of updated them this week. So there's one more concept left in this section. But let me make one up. The original f of x equals x minus x to the 5th power. I want you to determine whether this function here is even, odd, or neither, and then describe the symmetry. So I give you another 60 seconds to work on it. All right, any conclusions yet?
Is it
It's an odd function.
a odd
Odd function. All right, symmetry.
It's symmetrical about the origin.
Symmetric about the origin. All right. Does anyone want to see it? See the explanation. Put a 1 in if you want to see it. Okay, great. All right, so f of negative x equals, so you can kind of get in the habit of putting parentheses wherever you see an x. It's not necessary for all of it, but all right. So for that first part after the equal, is nothing really to do. I didn't really need to put that in parentheses. That was a little extra. So it's just negative x for that one. Minus, all right. Here though, we got a negative x to the 5th power. What is a negative x to the 5th power equal to?
Negative x.
Negative x to the.
Yep, it's a negative x to the 5th power. So when you drop that negative x to the 5th power, what's going to happen is that minus and this minus actually does change. Now that one actually changes in the middle because you already worked on your exponent, your parentheses, and then that exponent. So negative x plus x to the 5th. Notice that the original was x. It was a positive x. Now notice is a negative x. Notice that the original had a negative x to the fifth, and now is a positive x to the fifth. So it does satisfy that condition of all signs switching up to the opposite sign of the original function. So yes, it is odd. Odd is an odd function and symmetric about the origin. All right, any questions about even, odd, or even functions or odd functions? Tests for even or odd functions. All right. So last thing, you're probably going to have to take notes for this one, just in case you didn't print out these new notes. It's called the average rate of change. It says in section 1.3, which we did not cover because normally in algebra class, you've covered the slope of a line already. It says that the slope of a line can be interpreted as a rate of change. So in algebra class, you learn how to find the slope of a line. Now they're calling it finding the average rate of change. It's the same thing. And let me show you why. It says for a nonlinear graph, the average rate of change between any 2 points, x of 1, f of x of 1, and x of 2, f of x of 2, is the slope of the line through the 2 points. So guess what? You're not really doing anything that much different. It's just different notation because we're talking about functions. The line through the 2 points is called a secant line. So if you have a graph that's not a straight line and you're trying to find the slope, it's now called a secant line. And the slope of the line is denoted as m sub sec. And we'll talk about that. That's not football, y'all, even though I'm a big Alabama fan. Figure 1.39. All right, we have this graph and we have 2 points. Y'all notice the little 2 points. All we're doing is finding the slope of 2 points. Okay. So the average rate of change of f from x of 1 to x of 2 is this formula right here. This formula looks just like the wet formula. Again, just re-emphasizing it. It looks similar, very similar to the wet formula.
Slope of a line?
The slope, right. What's the only difference? Really, the f of x of 2. But what do we know about f of x? It's the same thing as what?
Y?
Y. All right. So f of x equals y. So notice these are just the change in y's, right? The change in y over the change in x, which is exactly what we used to say about slope. So we're not doing anything different, just different notation. And then it says m of s sub sec. What does m represent in math?
Is it the slope?
It's the slope. Anytime you see m, they're talking about the slope. Now you're gonna have to guess on this one. Why you think they have a little subscript sec?
Because it's secant line now.
Because it's secant line. Very good. Good guess. Secant line. All right. So what we're gonna do, I'm gonna show you how to do A, and then I'm gonna see if you can do B on your own here. Our example is find the average rate of change. Again, all we're doing is really finding the slope. Find the average rate of change of f of x equals x cubed minus 3x from x of 1 equals negative 2 and x of 2 equals negative 1. All right. First thing I want you to write for A. Let's go ahead and write f. I'm going to just rewrite the formula back over again. You don't have to, but I'm just going to rewrite it. Write that a little bit better. Do a little bit better, Shawanda. All right. X of 2 minus f of x of 1 over x of 2 minus x of 1. All right. Now I'm going to rewrite it like this. First thing I want you to tell me, what is x sub 2 in A? A gives us what x sub 2 is. What is it?
-1.
All right. Good. Then we got minus f of x sub 1. What is x sub 1?
-2.
-2. Good. So again, just repeat it in the denominator. X sub 2 over here is -1. And x sub 1 is -2. We're writing the same thing back over again. All right. Now, we got to figure out, how do we figure out what is f of -1? What does that mean? How do we figure out what f of -1 is?
By plugging in -1 where the x's are in the formula.
Plug in -1 where the x's are where?
X cubed minus 3x.
Very nice. Our function, they gave us our function here in the problem. F of x equals x cubed minus 3x. So what we have to do is evaluate, and you're going to hear that word a lot, evaluate the function at -1. So this is what you've been doing since day 2 of class. So we got to figure out first, what is f of -1? So I'm going to squeeze it somewhere at the top. So, well, I'll put it up here at the top here. F of -1 equals, and I'm looking at this, -1 cubed minus 3 times -1. All right. What's -1 cubed?
-1.
-1. What about minus 3 times -1?
Plus 4.
3.
Plus 3.
Plus 3. -1 plus 3 is
2.
2. Okay. So this right here equals 2. So what I'm going to do is write it here. 2 minus, all right. Now we need to figure out what f of -2 equals. All right. So I'm going to go all the way over to the left. F of -2 equals, again, we're using same function, -2 cubed minus 3 times -2. What's -2 cubed?
-8.
-8. All right, minus 3 times -2.
-6.
Plus 6.
All right. All right, 2 minus -2, and then at the bottom we have -1 minus -2 over here at the bottom. So that changes to -1 plus 2. All right. What's 2 minus a -2?
4.
4. So 4 in the numerator. What goes in the denominator?
1.
1. 4 over 1 equals 4. That is your average rate of change. Average rate of change. Or simply your slope. All right. All right. Let's try B. Let's try B. From x of 1 equals 0 to x of 2 equals 1. All right. So B, I'm going to put B down here. B. So again, you can write out the formula. Then we're going to plug in some values. So we're going to plug in x of 2 first. What is x of 2?
-1.
For B?
So it's 0.
X of 2
It's 1.
1.
is 1. All right. Uh-oh. I'm going to go ahead and put 1 at the bottom because we have to repeat x of 2 at the bottom. All right. What is x of 1?
0.
0. So I know the bottom is going to be 1. What is f of 1 equal to? So I want you to work on this. What is f of 1 equal to? Right there. Work on that. And direct message me the answer. Don't share it with everybody. Find my name on the chat and direct message me to make sure that I want to just know, do you know how to evaluate a function? What is f of 1 equal to? All right, direct message me or private message me. All right, Merritt, that's right. Uh-oh. Okay, here we go. Alicia, you're right. Are we having trouble with this one? 2 people answer.
I'm trying to figure out how to direct message on him.
Oh, okay. All right, Kenneth. All I want is what's the... Oh, you gave me the whole point. Okay, I got you, Kenneth. All right, Tanaya. All right. So if you go to the chat in the little box, find someone to chat with, you could just type in my name, see if it pops up. All right, Nakiria. All right, I'm going to go ahead. So you don't have to put in the chat if you don't. I just want to see if some of you got it. So the answer is -2. -2. All right, so let me work that out. Again, this is our function. F of 1 equals 1 cubed minus 3 times 1. So that's 1 minus 3, which is -2. Minus, what would be f of 0? F of 0.
Probably 0.
Probably. Yeah, it is. It is. All right. Plug in 0 wipes out everything. So -2 minus 0 is -2. And -2 divided by 1 is just -2. All right. So that's the answer to B. All right. All right.